Good day to you children. In today's class we will be learning about parallel lines and transversal. If you remember, then in the previous chapter, that is Introduction to Euclid's Geometry, before we learnt about the fifth postulate, I told you about the parallel lines and the transversal and the angles associated with them. So in this section of the chapters lines and angles, we will once again be visiting the parallel lines and transversal. So in the last time I told you that parallel lines are the lines which never meet. Those lines have a fixed perpendicular distance between them. Such kind of lines are known as parallel lines, and when a third line intersects these pair of lines, that line is known as a transversal. So if you look at the figure here, you can see three lines, among which two of them are parallel. Let's name them as line L and line M. Line L is parallel to M. That means the perpendicular distance between these lines is constant, or the lines never meet each other. And now this third line N is our transversal, because line N intersects our parallel lines at 2 points, that is P and Q. So write down in your notebooks the definition of the parallel line, that parallel lines are the lines which have a fixed perpendicular distance between them, and transversal is the line which intersects the parallel lines. That's the definition for parallel lines and transversals. Now in these parallel lines we have several sets of angles which are pretty interesting to study. Okay, let us first name the angles which are formed here. This is angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and lastly angle 8. So we have 8 angles when two parallel lines are intersected by a transversal. So now let us look at each of these angles and their individual properties. Alright, so here we have first something called as corresponding angles. Corresponding angles in the figure, if you remember from the last chapter, then you can easily spot the corresponding angles are the pairs of angles here: angle 1, angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. These angles are always in pairs. That means these angles are always as a set of 2. So the corresponding angles in this case are angle 1 and angle 5, top, angle 2 and angle 6, angle 2 and angle 6. Similarly, the bottom, angle 3 and angle 7, angle 3 and angle 7, and lastly angle 4 and angle 8, angle 4 and angle 8. These 4 sets of angles in our figure, where L is parallel to M and N is the transversal, are known as corresponding angles. And there is an axiom which states that, if you remember, an axiom is a statement which is considered to be the truth without any proof. So there is an axiom for corresponding angles. It says that if the lines are parallel, then the corresponding angles are equal. That is the axiom of corresponding angles. If any two or more given lines are parallel to each other, then the corresponding angles are equal. That is, from this figure we get, that is, angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 3 is equal to angle 7, and lastly angle 4 is equal to angle 8, because all of these angles are corresponding angles and they are equal when the lines are parallel. Also, there is a converse or reverse of this axiom which says if the corresponding angles are equal, then the lines are parallel. That is the reverse statement or the converse axiom of the corresponding angles. Now the second set of angles. Let's move on to the second set of angles, and before that keep in mind we assume that the corresponding angles are equal, and based on this assumption we prove that all the other set of angles which we get to study further in this section are equal. First, assuming that corresponding angles are equal, we will prove that the remaining set of angles are equal. So this is an axiom here, but the upcoming statements would be the theorems because they can be proved on the basis of this axiom. So moving ahead, the second set of angles which we have are alternate interior angles. Write it down, alternate interior angles. Look at the figure. The angles on the opposite ends of the transversal are known as alternate interior angles. So this is our transversal. Now interior part means the one which lies between the two parallel lines. This is known as the interior part. This is the exterior and this is also the exterior part. Alright, so since the angles lie on the interior side of the parallel lines, they are known as alternate interior angles. When they lie on the exterior parts, they are called as alternate exterior angles. So now look here, the alternate angles lie on the opposite sides of the transversal. Angle 5 and angle 4, angle 3 and angle 6 are the alternate angles, sets of alternate angles. So angle 4 is equal to angle 5 and angle 3 is equal to angle 6. They are equal. That is the theorem. When the lines are parallel, then the alternate interior angles or just alternate angles are equal. That is the statement of the theorem which can be proved. Theorem: when the lines are parallel to each other, they are right to each other, and the lines are parallel, the alternate angles are equal. This is our theorem on the alternate angles. Now the third set of angles is alternate exterior angles. We have interior, so we should write about alternate exterior angles. So from the figure we get angle 1 is equal to angle 8 and angle 2 is equal to angle 7 are the alternate exterior angles, and they are also equal when the lines are parallel to each other. That is also a theorem. And the last set of angles which we have is, the final set is known as angles on the same side of the transversal. Now if you look here, if you look at the figure, L and M are parallel lines. L is parallel to M and N is the transversal. Now from this figure, the angles which lie on the same side of the transversal, that is either on the right side or on the left side, are the angles on the same side of the transversal. But we are interested in just the interior angles on the same side of the transversal. So from the figure, the interior angles are 3, 4, 5 and 6 because they all lie on the interior part. And which of these angles lie on the same side? That would be angle 4 and angle 6. This pair of angles lie on the same side, whereas angle 3 and angle 5 lie on the other side of the transversal. And the property which is associated to these angles is that from the fifth postulate of Euclid, we studied it in the fifth postulate, right? Angle 4 plus angle 6 is equal to 180 degrees, and similarly angle 3 plus angle 5 is equal to 180 degrees. When the interior angles on the same side of the transversal are equal to 180 degrees, then the lines are parallel. That was the fifth postulate of Euclid. So, or conversely, we can say that when the lines are parallel, then the sum of the interior angles on the same side of the transversal is supplementary, or their sum is 180 degrees. Just like how alternate angles are called as alternate interior angles or alternate exterior angles are just called as alternate angles. Similarly, we can call these angles on the same side of the transversal as co-interior angles. This is another name for these kinds of angles. They are also known as co-interior angles. So from our figure, the angles on the interior part which lie on the same side of the transversal are known as co-interior angles, and their sum is equal to 180 degrees only if the lines are parallel. If we have non-parallel lines, then their sum will not be equal to 180 degrees. Moving on, now we have something known as lines parallel to the same line. So just like in the previous figure, we have two parallel lines, say line A and line B. This is line A and this is line B. Now we know that A is parallel to B. Line A is parallel to line B. Now I will draw a third line which is parallel to B. This is my third line which is parallel to B, and let us call it as C. From construction we have B is parallel to C. Now our job is to prove that line A, to prove A is parallel to C. A is parallel to B and B is parallel to C. We have to prove that A is parallel to C. So let us draw the transversal. This is the construction. This is our transversal N. So write it down. Construction draw a transversal N to the lines. Now we have three sets of corresponding angles here. This is angle 1, this is angle 2, and this is our angle 3. Okay, we get three sets of corresponding angles. So let us use that to prove that A is parallel to C. Proof. In A is parallel to B, that is given to us. A is parallel to B. This implies angle 1 is equal to angle 2 because they are corresponding angles. Similarly, B is parallel to C. This implies angle 2 is equal to angle 3 because of the same reason. They are also corresponding angles, angle 2 and 3. So now angle 1 is equal to 2 and angle 2 is equal to 3 from axiom 1, which says that things which are equal to the same things are equal to one another. From axiom 1 we get angle 1 is equal to angle 3. Now they are also corresponding angles, right? 1 and 3, they are corresponding angles of line A and C. And from the corresponding angles axiom, which said when the corresponding angles are equal, the lines are parallel, we get, this implies A is parallel to C. So this is the concept of lines which are parallel to the same lines. When we have two parallel lines and we have a third line which is parallel to one of those lines, then that line will be parallel to the other line. So statement of the theorem is, and its statement is, lines which are parallel to each other, to the same line, lines which are parallel to the same line are parallel to one another. That is if A is parallel to B and line A is parallel to line B and line B is parallel to line C, this implies A is parallel to C. This is our theorem which we just proved. Now let's move on to the solved example part of this section, in which we have 3 questions and I will be solving them for you. So in the first question, in the figure, PQ is parallel to RS. PQ and RS are two parallel lines. So they have told us that PQ is parallel to RS. Also they have informed us that angle MXQ, where is the angle? MXQ. So this angle is equal to 135 degrees. Similarly, angle MYR, that is this angle MYR, is equal to 40 degrees. We have to find angle XMY. We are supposed to find the value of this angle. So first let us write down given. Solution. Given PQ is parallel to RS and angle MXQ is equal to 135 degrees. Angle MYR is equal to 40 degrees. This is given to us. Let us draw line AB parallel to PQ. Now let us draw a new line AB which is parallel to our line PQ. So this is our new line AB. This is A and this is B. And we have AB parallel to PQ and PQ parallel to RS. This implies AB is parallel to RS. This is our result 1. When the lines are parallel to the same lines, then they are parallel to one another. Since AB is parallel to PQ and PQ is parallel to RS, we can say that AB is parallel to RS. That we got from our theorem. So now look here, PQ parallel to AB and XM is the transversal. Now PQ is parallel to AB and XM is the transversal. Right. Now angle MXQ plus angle XMB is equal to 180 degrees because they are co-interior angles. Since the lines are parallel, they are supplementary. This angle MXQ, this angle, and XMB, this angle. Both of these angles, sum of these angles is 180 degrees because they are co-interior. We know that MXQ is 135 degrees because it is given to us. 135 plus angle XMB is equal to 180 degrees. This implies, write the reason it is given to us. Now this implies angle XMB is equal to 180 degrees minus 135 degrees, which is equal to 45 degrees. So angle XMB is 45 degrees. Now similarly, this is our result too. Similarly, AB is parallel to RS and MY is the transversal. Using the same concept which we used in this part, now since MY is the transversal, we get angle BMY is equal to angle MYR because they are alternate angles. So since we know that MYR is equal to 40 degrees, this implies angle PMY is equal to 40 degrees. This is our result 3. Now we know that angle XMY is equal to angle XMB plus angle BMY, which is nothing but 45 degrees plus 40 degrees. We got it from result 2 and result 3. So angle XMY is equal to 85 degrees. This is our solution. In the second question, if a transversal intersects two lines such that, take note here that they have not given us that a transversal is intersecting the parallel lines. They have just told us that a transversal intersects two lines. We don't know if they are parallel or not. Right? If a transversal intersects two lines such that the bisectors of a pair of corresponding angles, right, whenever a transversal intersects lines, then it forms pairs of corresponding angles. They are equal or not, that depends on if the lines are parallel or not. And since we don't know if the lines are parallel or not, we don't know whether those angles are equal or not. So if a transversal intersects two lines such that the bisectors of a pair of corresponding angles are parallel, then prove that the lines are parallel. If the angle bisectors of the corresponding angles are parallel, we have to show that the lines will be parallel. So first let us draw a figure for this question. So let us draw a figure, and for your sake of understanding, here I am going to draw parallel lines, but we don't know if our given lines are parallel or not yet. Alright, we have to prove that, but just for the sake of understanding, I am going to draw two parallel lines. So now we have two lines L and M, and this is our transversal for the lines, and let us call it as AB, transversal AB. Now we have the angle bisectors to our pair of corresponding angles. They have told us that there are angle bisectors. So this is our angle, first corresponding angle, and here we have its pair. This is the parallel line. Sorry, this is the angle bisector, and this is our second corresponding angle. Now let us label them. Let this point be C, let it be D. Now we have the ray CE, and let this be the ray DF. Our job is to show that L is parallel to M. So first let us write down solution to prove L is parallel to M. Given CE is parallel to DF. They have told us that the angle bisectors are parallel to each other. So now proof angle ACE is half of angle ACX. Look here, angle ACE, this is angle ACE, and it is half of angle ACX because CE is the angle bisector. We know that. They have told us that the angle bisectors are for the corresponding angles. Similarly, let this be result 1. Similarly, in the pair angle CDF is half of angle CDY. You can write it, right? Angle CDF is equal to half of angle CDY. This is our second result, because DF is the angle bisector, right? Also, CE is parallel to DF. They have given us. This implies angle ACE is equal to angle CDF, right? CE is equal to DF. AB is the transversal, right? Then angle ACE and angle CDF are our pairs of corresponding angles, because they are corresponding angles. When the lines are parallel, the corresponding angles are equal. This is our result 3. From 1, 2 and 3, we can write, since ACE is equal to CDF, we can write half ACX is equal to half angle CDY, right? Half angle ACX is equal to half angle CDY. Half cancels each other. We have angle ACX is equal to angle CDY. But now look here, angle ACX and angle CDY are the corresponding angles for the lines L and M, and they are equal. So what does the converse axiom say? When the corresponding angles are equal, then the lines are parallel. That is the corresponding axiom. Therefore, since angle ACX and angle CDY are corresponding angles of lines L and M, we get L is parallel to M, because, write the reason, converse axiom of corresponding angles. So if the angles are equal, then the lines are parallel. Hence, proof. This is our proof. In the last solved example, in the figure, AB is parallel to CD and CD is parallel to EF. Also, EA is perpendicular to AB. EA is a line segment passing through these parallel lines and it is perpendicular to the line AB. If angle BEF, that is this angle BEF is equal to 55 degrees, then our job is to find the values of X, Y and Z. So solution given angle BEF is equal to 55 degrees. Now I can write it as angle BEF plus Y is equal to 180 degrees because CD is parallel to EF and this line EB is the transversal, and angle BEF and angle Y form the co-interior angles. They are co-interior angles formed by the parallel lines. So this implies Y is equal to 180 degrees minus angle BEF. So Y is equal to 180 minus 55. This implies angle Y is equal to 125 degrees. This is our result 1. We know that X is equal to Y. Look at the figure. AB is parallel to CD and EB is the transversal. Just by looking, we can say that angle X and angle Y are the corresponding angles of parallel lines. So they are equal. So X is equal to Y because they are corresponding angles. This implies X is equal to 125 degrees from result 1. So we got the value of angle Y and we got the angle of angle X, but the only thing remaining for us to find now is the value of angle Z. Here you will find that angle BAE, we know that AB is parallel to CD and CD is parallel to EF. This implies AB is parallel to EF and EA is the transversal. Right, if you look at the figure, you will find that EA is the transversal for the lines AB and EF, which are parallel to one another. Therefore, from the figure, I can write as angle BAE plus angle FEA is equal to 180 degrees because they are co-interior angles. But we know that angle BAE is a right angle which is equal to 90 degrees plus an angle FEA is made of two angles. One is angle Z plus angle BEF. These are the two angles which it is made up of, and this sum is equal to 180 degrees. So this implies 90 degrees plus Z plus 55 degrees because we know that BEF is 55 degrees, which is equal to 180 degrees. So Z plus 145 degrees is equal to 180 degrees. This implies Z is equal to 35 degrees. This is the required solution. For your homework, I am giving you the first main from the exercise 3.2. In the question, in the figure, find the values of angles X and Y. So this is the figure which you can see in the video here. your job is to first find the values of angles x and y given the angles on the top here. The angle which is in linear pair with the angle x is equal to 50 degrees, and the angle which is vertically opposite to the angle y is angle 130 degrees. So first your job is to find the values of angles x and y, and then you have to prove that the lines AB is parallel to CD, where EF is our transversal. The line intersects the lines at points E and F, so EF is our transversal line. I hope you guys solve it in your homework book, and for the next class I'll begin with exercise 3.2 from the second main. That's all for today. Thank you.